Welcome to this video, which is designed to give an introduction to Kirchoff's laws, the application of Kirchoff's law to electric circuits. In this circuit, we have two batteries, a 12 volts battery and a 15 volts battery and a 12 volts battery. We have three resistors, R1, R2, R3. Looking at this circuit, it is very difficult for you to simplify the resistors to say R1 and R2 are in series, R1 and R3 are in parallel, because for us to say two resistors are in series, the same current should flow through them. And for us to say they are in parallel, the same potential should drop across them. But looking at R1 and R2 and R3, we can really say that it's possible to have different currents to flow through each of them. And it's also possible to have different potentials to drop across each of them. Okay. A simple way to resolve this is to apply Kirchoff's law. Kirchoff's law, there are two variants, the Kirchoff's current law and the Kirchoff's voltage law. So we've assumed that current I1 is flowing in this through resistor R1. That means current I1 will flow through this channel. We also assume that I2 is flowing in this direction, meaning that I2 will flow out of this battery through resistor R2 to this junction. And like we've said earlier, Kirchoff's current law tells us that the current that will flow into this junction will be equal to the current that will flow out of the junction. So that means that I1 plus I2 will add up to give us I3 that will flow through resistor R3. When I3 gets to this junction, it splits back into two. It splits back into I1 and I2. So that means I3 will flow into this junction and will split into I1 and I2. So a simple mathematical meaning of what we have just said is that Kirchoff's current law has said that I1 plus I2 equal to I3. Then the Kirchoff's voltage law. Kirchoff's voltage law tells us that the algebraic sum of voltages in a closed loop is zero. So we'll take this as a loop A, and we'll take this as loop B. And the direction of this arrow tells us how we are going to navigate the loop. So from this, in this loop, we'll say that the voltage is 15 volts. And the loop is in this direction. The voltage, when current will flow out of the battery, we expect it to flow in this direction. And since our loop agrees with the direction with which we expect current to flow out of this battery, then easily we say 15 volts. Then we get to this resistor R1. R1, this is direction of our loop. It also agrees with I1. So I1, since I1 flows through R1, it means that I1 R1 has dropped in this circuit. Because the direction of our loop, direction with which we are traveling through our loop, agrees with the direction of flow of I1, then that will be a minus. And that will mean I1 R1 minus I1 R1. Since R1 is 4 ohms, then minus I1 will be minus 4 I1. Then coming to this resistor R3, the direction with which we are navigating the loop also agrees with the direction of current I3. That means a voltage of I3, since I3 will flow through R3, a voltage of I3 R3 will also drop. And that's since R3 is 2 ohms, then I3 R3 will be 2 I3. Then, because the direction of I3 agrees with the direction with which we are going through the loop, that's why we have minus. And the product of resistance and current is voltage, which is 2 times I3. So getting to this point, we are returning back to the battery since we are navigating through loop A, and then that will be equal to 0. Then on loop B, we have decided to travel in this direction for loop B. When you look at the direction with which we have decided to travel, it agrees with how current should flow out of the 12 volts battery from positive to negative. It agrees with the loop. So we say 12 volts. So we have left the 12 volts battery. We are now at resistor R2. The direction with which we are traveling agrees with the direction of I2. Then we can say that the voltage of I2 R2 has dropped. Since I2 R2 has dropped, then we can say, and R2 is 3 ohms, then we can say 3I2 has dropped. And that will mean minus 3I2. Moving forward, we have left the 12 volts battery. We have left R2. Now we are in R3. The direction with which we are navigating the loop agrees with the current flow of I3, meaning that I3, which flows through R3, will cause a voltage drop of I3 R3. And since R3 is 2 ohms, then a voltage drop of 2 I3 will drop. Since the direction of travel of navigating through the loop agrees with the flow of I3, then we'll still come to say minus 2 I3. And that is equal to 0. So from these equations, looking at equations A and B, we can replace the I3s we have here with I1 plus I2, since I3 is equal to I1 plus I2. So writing that easily, we can say equation A and B will become 15 volts minus 4 I1 minus 2 I1 plus I2 equal to 0. And that will mean 15. Let's ignore volts for now. Let's ignore the units for simplicity. Minus 4 I1 minus 2 I2 minus 2 I1 minus 2 I2 equal to 0. And that will lead to saying 15 minus 6I1 minus 2I2 equal to 0. So let's write the value we require up here. Let's store this up here to say 15 minus 6I1 minus 2I2 equal to 0. Okay, for the second equation, we are going to also expand. We're going to expand this to give us 12 minus 3I2 minus 2I1 plus I2. Since I1 plus I2 is equal to I3, then I've replaced the I3 here with I1 plus I2 equal to 0. So we can expand a bit further to say 12 minus 3I2 minus 2I1 minus 2I2 equal to 0. Then that can be simplified. Let me move up here. That can be simplified to say 12 minus 2I1 minus 5I2 equal to 0. Now let me rub this off. So this is equation D, and this is equation E. So when we solve equations D and E simultaneously, we obtain 1.1.62 ampere. I3 to be 1.96 feet ampere. So what this means is that from our original circuit, the current that is flowing in this direction, I1, is 1.96. Let me clean this off. 1.96 1.96 ampere, and I2 is 1.62 ampere. R3 is 3.58 ampere. So it means 1.96 will flow to this junction, 1.62 will flow to the same junction, and will merge as 3.58 amperes to flow through R3. On getting to this junction, 1 point is split into 1.96 and 1.62. And 1.96 continues the journey through R1, gets to this junction, while 1.62 continues flow through R2 and gets to this junction, and both of them will reunite again to give 3.58. And that's what we have over and over. So let's have a similar example in the next video.